All right, so here we are doing homework 4. This is one where we have to calculate the soil expectation value or the bare land value of a 250 acre forest plot where a Douglas fir plantation with the following costs and revenues is planned. Discount rate is assumed at 6%. So we have this list of activities that we're going to do over and over. So if you remember, soil expectation value is perpetual, just like it was in our examples. And what we're going to do is work through this problem. So first thing we want to do in this case is like our other one. We know that it is going to be a perpetual periodic, right? So we're going to have this VO and then N years out and 2N and 3N and on. We're going to have this A that it's going to solve here. And so like we did in that example, these are supposed to be even distances. Ignore that, right? We want to use maybe just what that A is. If we can crunch all of these into a single A first, we can then apply that perpetual periodic once and get to this answer. So we know that the equation that we're going to use eventually is a payment at every N years. So not every year, it goes on forever. And it is this perpetual periodic equation. So our VO is going to equal A over 1 plus I to the N minus 1. And if we apply that, it solves this value here. But we have this problem where we have a single rotation, right? We have year 0, year 10, year 30, and year 40. We have things happening, right? We have a negative 200, we have a negative 160, we have a 1500, and we have an 8400. So what I could do is I could do this independently for each one, but when I do it, it's not going to always solve at year 0. Or like I had done in the example in class, we can take all of these and move them out to the end first and then get a single value of an A there. So typically what we've done in our problems, right, is that we've just applied these kind of crunching values of these seriatic things into a single value, these series to a single value, and then we've moved that single value using these ones afterwards. So this week we were looking at doing this first so that we only have to do this part that is more complicated once, right? So if we do slide that out, and slide that out to where we want it, the 8400 is already there, we have our A exactly where we want it, where if we apply this once, it gets us the VO where we want. So if I was wanting to know then what my A is, right, I could do taking the negative 200 out to the end. So I'm going to do times 1.06 to the 40. So what that is that's taking the future value here, the VT, right? So I'm going to move it out with simple compounding from here to here so I can add it to that 8400. I'm going to subtract off the 160. I have to take that out 30 years to get it to the end. So 1.06 to the 30. I'm going to add in my 1500. This is this thinning revenue, and that has to go out 1.06 to the 10. And I can then add on my 8400. It's already there. I don't have to do anything to it. Or if you think about 0 years, that's 1.06 to the 0, which is just 1. Okay, so now my A is going to equal, if I add all that together and do all those out, I will get 8110.17. Okay? So now we're going to move through and we have our A. So our A is going to equal the 8110.17. In the spreadsheet, you'll see the individual pieces if you want for that. So I'll do a spreadsheet key for this as well. And the I is 6% and the N is 40 years. We're doing it every 40. So that's our equation. Our VO equals 80.1017 over 1.06 to the 40 minus 1. You could bracket that a couple times there, and that's what we get. So that is 873.40, and that is dollars per acre, right? Because these are all dollars per acre that we have here. That is the value of an acre of dirt, but I have 250, if I wrote it right, acres times 873.40 dollars per acre, and that gives me a total value here of 218,350.63. Right? That's the value of 250 acres of bare land in this case. We'll use that later. So let's start into that later now. So now we have part B, where we need to assume that the forest plot is 28 years old. We hardly ever have forest plots that are an acre of dirt when we're looking at them. We typically have trees out there or some sort of initial condition. In this case, they're 28 years old. So I need to think about where I am on this timeline at 28 acres, and that becomes my timeline, because I'm going to get the land and timber value. So my VO or my LTV right now at year 0. The next thing that happens here, in 2 years, because it's 28, when it's 30, I'm going to get $1,500 an acre. And then when I wait 12 years, that's when it's 40, I get $8,400, right? And then I would plant it and do all of those things that we do. I have an acre of dirt left over after I harvest it. I've already solved what an acre of dirt is worth, and so I also get $873.40. All that happens here, and I can just add it together. So that's my land and timber value. So this LTV, or my VO in this case, is going to equal $1,500, and I'm going to discount that. So that's a single sum that I'm going to basically slide that way using discounting, and that's 1.06 to the 2, and I'm going to add to that my 873.40 plus 8,400. I can add them together because they're in the same year. They both occur in that same year, and I discount that 1.06 to the 12. Right? That's it, and that covers all future activities on this land because I buried them all in this bare land value. This is perpetual, so this land and timber value is perpetual, right? And when I add that together, I get 5943.59, and that is dollars per acre. So again, I have 250 acres times 5943.59 dollars per acre, right? The acres are going to cancel out, and I would get 1,485,897.90 dollars. That's the value at 28 years old of this property that's 250 acres. So, hope that seems straightforward. We get the value of an acre of dirt. We use that value here because that makes everything that we do here perpetual because it's carried here. But we don't get dirt until 12 years from now. And in our example, we have 2 activities that happen till then. We make sure everything's in the same year and we move it forward. Okay, so let's move on to 1C. So 1C says a new riparian rule is enacted that requires a 50-foot no-cut buffer on a stream that crossed this property, this 28-year-old acres from 1B. The area of new buffer on that stream in which no harvest will be allowed is 10 acres. So 10 acres of this 250 acres is going to be a stream buffer that you can't harvest. What is the reduction in property value associated with this rule to this landowner? Okay, So in this case, we can bring our land and timber value that we did on a per acre basis, and that was 5943.59, right, dollars per acre. All right, and that's just our answer from over here. Okay, so we're going to use that, and we're going to say the cost of the rule to this landowner is going to be 10 acres, where they used to be able to have 5943. Now they have 0 in revenue. Yes, there may be other values out there, but perhaps not to this landowner. We can't say. So what we're saying is the financial cost to this landowner of this rule is 10 acres times 5943.53.59, which equals $59,000 $435.92. That's the cost of this rule to this landowner. So they're probably not going to like it that much unless they value particularly riparian habitat on their land at that value. So in a lot of cases, what it ends up being is that we as society have those values, and so it's a lot of other people's values as well. That's not for us to say. We're just in charge of figuring out what the financial cost is. Okay, so now we have a different one. So suppose the same property, right? We have a neighbor that was burning some debris piles, and the fire got out of hand and completely burned 50 acres of their property. Just burned it to the ground, right? This is the 28-year trees, the same thing. What's the financial loss associated with this fire? So here, right, what we want to know is what we had before. So just like the one up here, right, what we had before was 5943.59 dollars per acre. And we want to know what we have after. Right, up here it was 0 because you weren't going to be able to do anything, so you weren't going to ever get to any of these future activities that you had. So we use 0 up here, but here it's not 0. You have an acre of dirt, and we know what that's worth. That's worth $873.40 per acre, right? That's what we got. That's our soil expectation value. So they're going to have a cost up front, but they're going to get all these future returns. So they don't go to 0 in this case. The land has the value in the future, or financial value in forestry. So that's what we have. So the loss on a per acre basis is going to be that minus that, which equals 5070.19. That is dollars per acre. And we've got 50 acres. Is just going to be 50 times that amount, which is 253,509.45. That's the loss of that fire. So that's what you should be seeking in compensation if you're going to either present it to insurance or present it to that landowner and demonstrate what the financial cost of that fire was. So hope that helps you guys. I'll post a sheet, looks a lot like this out there, and there'll be another video with problem number 2.